Solve the inequality 8a minus 2 is greater than or equal to 13a plus 8. To solve this, we treat this like an equation. I'm going to try and isolate the a. For this problem, I'm going to subtract 13a from both sides of the inequality first. The 13a's will cancel on the right side of the inequality. 8a take away 13a turns into negative 5a. We bring down the rest of the terms. Minus 2 comes down, greater than or equal to 8. Next, we're going to move the 2 to the right side of the inequality. To cancel the minus 2, I will add 2 to both sides of the inequality. Minus 2 and 2 will cancel. 8 plus 2 makes 10. To solve for the a, I need to divide out by negative 5. And this is where one of the rules will change that's different from regular equations. When you multiply or divide by negative numbers, the direction of the inequality will flip. So instead of saying a is greater than or equal to, now we're going to write a is less than or equal to negative 2. So this is our number line. So if I mark 0 here, this will be 1, this will be negative 1, negative 2, negative 3. And our number line goes in two directions. A is less than or equal to negative 2 means my interval will start at negative 2, including the negative 2 value. And all the values that we select must be smaller than negative 2. So this number line represents the possible values of a. The values on the left side of negative 2 are smaller than negative 2. So we're going to select that region by shading in this space to the left. And that would indicate our solution. Solve the inequality x plus 8 is greater than or equal to 4x plus 17. To solve this inequality, I'm going to isolate the x again. I'm going to move the x to the right side of the equation. So I'm going to cancel out the x on the left. This is a positive x. I'll need to subtract x to cancel it out. We have to balance the operation, so we have to subtract x on the right side of the inequality as well. We're left with 8 is greater than or equal to 4x take away x becomes 3x, and then plus 17 comes down. To isolate the x, I'm going to subtract 17 from both sides of this inequality. 8 take away 17 becomes negative 9. Is greater than or equal to 3x. And this goes out. Lastly, we'll divide both sides of this inequality by 3. 3's will cancel. Negative 9 divided by 3 is negative 3. Is greater than or equal to x. Here's our number line. I'll go ahead and mark the arrows. This time negative 3 is our point of interest. So I'll go ahead and mark 0 here. This will be negative 1, negative 2, negative 3, negative 4. Since my x actually lands on the value negative 3, I can go ahead and put my shaded circle on that. if I read the inequality, it says negative 3 must be greater than or equal to the values of x that we select. So if I'm shading the values of x, that means negative 3 has to be the largest value of this interval. Or I have to say that the values I pick are smaller than negative 3. So let's pick a number on each side of negative 3 and see which of those numbers would satisfy this inequality. If I choose a number on the left, let's say I choose negative 4. Is negative 3 greater than or equal to negative 4? That is true. So I know that this side contains the values I want to shade. What if I chose the other side? Let's say I chose negative 2. Is negative 3 greater than or equal to negative 2? That is not true. So I'm going to not shade this side. Okay, so we know that we should shade on the left side of this graph when we graph this one-dimensional inequality.